Okay. Mm. So today's session we are going to discuss on Numpy, numerical Python. So from today onwards, what I can say is that we are going to go into the core part of data science, where these packages, whatever we discuss, will be mostly used in data science. Uh, what is it? Data science concepts and all. Okay. So we shall discuss more about NumPy, and we'll discuss about pandas next, and then we'll do a lot of small code basis code snippets and all. Okay, let's see. Uh, so NumPy, or we'll call it as NumPy arrays generally. Okay. Uh, so let me write. So NumPy arrays. Okay. So we have dealt with list, set, tuple, dictionaries, like different kinds of data structures, right? So NumPy arrays are nothing but, like, you can consider these as matrix. Okay, matrix. Okay, so matrices which consists of rows and columns in your data. Okay, so it's a matrix where you have one-dimensional data, one-dimensional, uh, two-dimensional, and three-dimensional, and so on. Okay, but for our eye, we can only visualize maximum up to three-dimensional. We cannot see more than three dimensions generally. Okay, so if your data set consists of more shapes, okay, so obviously we cannot visualize, but what I can say is that there is a lot of n-dimensional data that is possible to create. Okay, so that's what I can say. And coming to the arrays, we are going to create all these arrays. We are going to see the methods that we can apply on these arrays. Okay, and we'll see creating arrays. Okay, and methods in NumPy. Okay, methods are functions, you can say. Methods are functions, and yeah, we'll also see indexing. Okay, indexing in arrays. Yeah, all that we'll see. And extension of this NumPy arrays I'll discuss with another package called computer vision. So that is more complex or more intellectual concept. But let's first discuss on this NumPy, and then we'll see what we'll do next. Okay. So let's start creating a NumPy arrays. Okay. So first of all, to use this package, we need to import it. So import NumPy. Okay, import NumPy. Or instead of using NumPy always, you can put an alias np. Okay, so that whenever you say np, that is referring to the package NumPy. Okay, so whatever the methods, okay, whatever the functions that are there, you can call NumPy np dot and click on tab, and you will see a lot of mathematical functions that will be there inside it. Okay, these are all mathematical functions, numerical functions that are present inside your NumPy package. Okay, now first of all, what we'll do is we'll create an array. Okay, we'll create an array. So we can create array with in the one-dimensional data, two-dimensional data, and three-dimensional data. More is possible. Okay, so what we'll do is, so first of all, let's create a data using a function called array. Okay, np dot array. Okay, np dot array. So inside np dot array, you can pass your data. Okay, you can pass in your data. So say for example, I'm passing a list of values 1, 2, 3, 4, and 5. Okay, so this is an array that I'm creating. So let me store this in a variable array1. So let's print array1. Okay, so you can see this is an array. Okay, this is an array. So for this one, if you want to see what is the dimensions of this data, okay, how many dimensions are there for this data? So generally dimensions I'm representing nothing but in matrix. So normal dimensions will be n rows, m columns, n by n length simple, right? So like that. So if it is two dimensional, we have n rows and columns. Okay. If it is one dimensional, it will be only what I can say is like there won't be any columns. Okay, only a single row kind of data. Whatever the data it comes, everything will be in a row. Okay, there won't be any columns and all like that. So if it all comes into three dimensions, there will be more dimensions like uh, uh, you can say depth kind of it. Okay, so depth also. So let's see the shape. Okay, shape of an array. So how many dimensions like that we want to see. Okay, so to check how many dimensions, we just need to put array1 dot shape. Okay, so now currently it is showing 5 comma. Okay, 5 comma. The meaning of it is nothing but it is a one dimensional data. Okay, it is a one dimensional data. If you are showing 5 comma 1 something like that, then that means two dimensional data. Okay, it is a two dimensional data, but here it is representing only rows. Okay, only 5 values are present here. So this is clearly stating that it is only a single dimensional data. Okay, so I'll tell you how to create multi-dimensional data also, but for now let's create one more array. So here we have passed a list to create our array. Now let me pass a tuple. We can also pass a tuple. Okay, array2 is equals to np dot array of, we can pass in a tuple 1 2 3 4. Okay, execute, and array2 is printed. The output is same. Okay, if you see, the output is same whether you pass in a tuple or whether you pass in a list. Okay, anything, so it will be the same. Okay, so this one thing. So array2 dot shape, same thing. Okay, array2 dot shape, so this is same thing. Now if you wanted to create uh, two-dimensional arrays, okay, two-dimensional arrays. So till now we have created one-dimensional array. So these are all one-dimensional data. So 1D arrays. Okay, now let's create two-dimensional arrays. Okay, so 2D arrays. Okay, so now what I'll do is, so let me create an array 3 np dot array, and inside, so what you have to do is you have to put, I'll put the same 1 2 3 4 5. Okay, but I will put in list of list. Okay, I'll put it in list of list. So execute this one. Now array 3, it is a slight different. Okay, the output is a little bit different from above. So you can check the shape, array 3 dot shape. So it says one row and 5 columns. Okay, one row and 5 columns. So it is clearly two-dimensional data. Okay, it is clearly two-dimensional data. Let me create one more array. np dot array of. So what I will do is, it's a bigger list. So inside of this list, I will add two lists. Okay, so 1, 2, and 3, and 4. So this one will be 4, 5, 6, and 7. Okay, execute this. No, sorry, I'll put this array 4. So this will be array So array 4 looks like this, and you can check the shape. Array 4 dot shape is 2 rows and 4 columns. Okay, 2 rows and 4 columns, like that we are mentioned clearly. Okay, and if you want to change, let's say if you want to change the shapes from, let's say, 2 rows to 4 columns, instead of two rows 4 columns, we can change it into multiple shapes. Okay, so generally uh, a 2 comma 4 array can be converted into 1 comma 8, 1 row 8 columns, or 8 rows 1 column, or 2 rows 4 columns, obviously it is already having, or 4 comma 2. Okay, like this, these many number of ways we can reshape. Okay, this many number of ways we can reshape. So for now, uh, I will tell you later how to reshape your data. So simply using dot reshape function, I'll tell you that. But we have seen 2D arrays, 1D array. Now let's see three-dimensional data. 3D array. So to create 3D arrays, so we just need to put. So let me create an array. 5. Okay, np dot array. Okay, so np dot array. Previously we have kept this one in a single, list of lists. Okay, so now this one will be multiple list of list. Okay, multiple list of list. So multiple list of lists. Let me add one more here. One, like this. Okay, so 1, 2, 3. Okay, and what I'll do is I'll add 4, 5, 6. Okay, so this is one input. Okay, this is one input, and next one will be comma. I will add a bigger list, and inside of it 2 smaller lists. So I write 7, 8, 9, 10, 11, 12. Okay, so this is how it works. So let me just okay, so this is how it works. So in a bigger list we are putting a two-dimensional data. Okay, so execute this and click array 5 dot shape. So it is clearly saying the depth here. Okay, it is clearly showing the depth also. Okay, so like this you can create three-dimensional data. Okay, so this part is two-dimensional data. Okay, and this only part is one-dimensional data. This whole bigger part is two-dimensional data, and this whole bigger part is three-dimensional data. And for adding 4 dimensions, putting three-dimensional data in a bigger list. Okay, simply that is 4-dimensional data. Okay, so that will be showing as another dimension. We cannot name it also, but you can do it anyway, like for length, breadth, height, width, so like that. So different dimensions you can add for your data. That's your wish. Okay, but here, so you can see n rows and columns and depth of the data. Okay, and one more thing, for any kind of an array, if you wanted to see how many shape or anything, so either you can use dot shape. Okay, or you can use dot n dimensions. Okay, you can just print the n dimensions thing. So array 5 dot n dim. So it shows 3 dimensions are there. Okay, and array array4.ndi. So it's a two-dimensional data. Okay, array1.ndim. So it is a one-dimensional data. Okay, so to find the dimensions of the data, to find the dimensions of the data or array, dimensions of an array, you can use .ndim function. Okay, .ndimensions function you can use. So that's what. So .ndi is going to show you how it is going to how many dimensions are there. It is going to show. Okay. Yeah. So I have shown you how to create different dimensions of data in an array. I have shown you how to check the shape, how to check the dimensions, and the next thing is how to reshape the data into different shapes. Okay, so for this one what we can do is we can use dot reshape function. So let's take array 3. Okay, so this is array 3 which has shape of array 3 dot shape 1 comma 5. The only way that we can do reshape for this one is 5 comma 1. Okay, 1 comma 5 can only be reshaped as 5 comma 1. So we can use array 3 dot reshape. Okay, reshape of 5 comma 1. Only this is possible. So if you wanted to reshape in 5 rows and 1 column, you can pass it like this. Okay, so this is 1 row, this is another row, third row, fourth row and fifth row, 5 rows and one whole column, one single column. Okay, like this you can reshape. And if you try to reshape in any other way you want, like let's say 5 comma, so we are converting this into a one-dimensional data. Okay, now this converts the array to one dimension. Okay, because you can see here it is only a single list, not in a list of list. Okay, so like this, if you give the shape 5 comma, it will become one dimension. Okay, and one more thing, it is not going to store. To store again you have to create another variable. Okay, so let's say array 3, it is still the same. Okay, so if you doing reshape of 5 comma 1, 5 comma 1, so you have to store it in array 3 1. Okay, so let's say this is my new array. So array 3 1 is my new array. Okay, and now check the shape, it will be 5 comma 1. Okay, like that. So like that you can do the reshape. Okay, for anything you wanted to do, you can do the reshape. Array 4. Okay, array 4 dot reshape. Okay, array 4 dot reshape. So this one is 2 comma 4. Okay, you can change it to 4 comma 2. Okay, or you can change it to 1 comma 8. Sorry, array 4. Okay, so like this it happens. Or array 4 dot reshape of 8 comma 1. Okay, so whatever the possible ways that it can do, it will do. Okay, whatever the possible ways that it can do, it will try to do it. Okay. Yeah. So this is how we can create we can reshape different arrays into different shapes. Okay, so next thing that I wanted to show is While discussing while loop, I have introduced you to one concept, one package called random. Okay, so that random package is already present inside Numpy package. Okay, so let's use it. So random package. So np dot random. So a random package is already present in NumPy. So you can call it using np.random. Okay. So when we use random package, we have called random integer. Okay, we have tried to generate random integers, right? So random dot rand int. Okay, random dot rand int. So we need to mention uh, the any range between. Okay, it will just generate a random number between that. Okay, it will generate a random number between that. But so my question will be something like this. So generate 100 random numbers between 10 and 10,000. Okay, with a shape of, so 100 random numbers can be shaped as 10 by 10 matrix. Okay, 50 by 2 matrix, 2 by 50 matrix, 25 by 4. Okay, 4 by 20, sorry, 25 by 4, yeah, 4 by 25. Okay, 20 by 5. Okay, so like that, different ways we can shape. So what I'll use is, I'll use with a shape of 10 rows and 10 columns. Okay, 10 rows and 10 columns, which is 10 by 10 matrix. Okay, which is 10 by 10 matrix. So I wanted to create a matrix like this. Okay, so for creating 100 random numbers between given range, so what you will do is np dot random dot random int rand int. Okay, you can use starting as 10 ending as 10,000. Okay, here what you can do is you can put shape. Okay, you can put shape here, or if I put 100, it will generate 100 random numbers. Okay, it will generate 100 random numbers. Okay, execute again, another 100 random numbers. So what I'll do is, instead of putting 100, I'll put a matrix here, 10 comma 10. Okay, uh, I'll put 100. So I'll copy the same thing, I'll write here. Okay, so I'll generate it as 10 comma 10. Okay, so this one says starting number, this one says ending number, and this says what is the shape. Okay, what's the shape of the matrix that you wanted. So I want 10 by 10 matrix, that means 100 random numbers. So a matrix, you can see the difference, it is only a single list here, it is list of lists. Okay, list of lists, clearly 10 rows and 10 columns. Okay, 10 rows and 10 columns are present here. Okay, 10 rows and 10 columns. So we are generating some random numbers like this. Okay, so let me create an array for this one. Array 6. So array 6 is this array. Okay, but when you execute, you will get different numbers. When I execute, we'll get different numbers. But if we wanted to have same numbers generated, okay, if you and me both wanted to have same numbers generated, what we'll do is, we have to use something called seed. Okay, so generate random numbers, same random numbers for everyone. Okay, so if someone looks like this, what we can do is np dot random dot seed. Okay, seed. So inside seed you can mention any number, which everyone has to mention the same number. Okay, so if I put 0 and now I call this, okay, array 7. So let me execute this. Now array 7 will have this particular data, and even when you use np.random.seed of 0 and execute random in the same code, you will also get the same numbers. Okay, same numbers. If I change this seed number to 0, some another number, so let's say some 1 lakh or 10 lakh, whatever it is. Okay, so okay, seed must be between 2 power of 32 minus 1. Okay, so let's do that. You can give something else, 999. Okay, so execute it. So for 99999, so this is the order. Okay, this is the order that it comes. This is the only data that comes if you are putting 999. If you are changing to something else, okay, so if you are giving something else, so this is another number, random number. For this particular number, this is the order, or these are the numbers that will be generated. Okay, for a 10 by 10 matrix. So if you change the shape, let's say you wanted to have, okay, I'll copy this one and I'll paste it here. I'll change the shape to, let's say, 2 comma 2. Okay, 2 by 2 matrix, and I'll put it as array 8, array 8. You can see here 9749 9749. Okay, 8796 8796 and 316 316 and 8108 8108. Okay, so the first 4 numbers are present here. So these are the first 100 numbers that will generate when we use this seed value. Okay, and these are the first 4 numbers that will be generated when we use this seed value. Okay, so same number, if you guys are using same seed number, so that the output will be same for you and me both. Okay, everyone will have the same output. So that is the usage of seed. Okay, if everyone want to have the same random number, so then you have to use seed. Okay, if you don't bother about same output or same number to be generated, so seed can be ignored. Okay, that's your wish. So this is how we can generate random numbers, same random numbers for everyone. Okay, same random numbers for everyone. Okay. So here we are generating random numbers with the shape of 10 comma 10, some random numbers. But normally without Numpy or without random package or anything, so we can generate using range, right? So but it will have uh, some ordering. Okay, it's not random. Okay, it's not random, right? So when we do this, it will follow an order. Okay, if I put 10 comma 10,000, it will generate 10,000 10 to 10,000 numbers. Okay, or if I use any step value, like let's say 100, so there's a 100 gap, like that you'll get. Okay, but in the same way, this kind of scenario we can do it in Numpy package as well. Okay, we call that as arrange. Numpy dot arrange, array range, and Numpy dot array range. Okay, you can mention the starting value and stopping value, start, stop, and step. Okay, you can mention the 10, 10,000, and 100. So it will generate 100 random numbers. Okay, it will generate it will give the step value like above. Okay, it will give the step value like above. Okay, so the same happens here. Like the shape will be only like above. Okay, it will be a single dimensional data. It's not a two-dimensional data. Okay, it's not a two-dimensional data, but we can do this using a reshape. Okay, so 10 comma 10. I hope this works. Yeah. So when you do 10 comma, obviously we have generated 100 values. Okay, 10 comma 10,000 comma 100 means we are getting 100 values. So that I am reshaping using 10 comma 10. Okay, so like this you can generate a range. Okay, using Numpy. Either you can use range, normal range, or you can use a range. Okay, using Numpy. Okay, I just wanted to introduce you to this part. Okay, and then after that, what we can do is so generate random numbers. So we have generated random numbers which are integers, right? So random numbers with negative. Okay, random negative numbers. Okay, random negative numbers. So let's do this. Okay, so for generating negative random numbers, what you can do is np dot random dot rand int. So you can mention the negative value starting with some negative. So let's say minus 10,000 comma plus 10,000. Okay, I will generate a shape of uh, 20 comma 5. Okay, that means 100 values only, but the shape changes. Okay, so you can see here 20 comma 5, 20 rows and 5 columns. Okay, so I'm getting negative data as well as positive data, and I'll also use seed. Okay, so np dot random dot seed of, let's say, 10. So this is a fixed value that you will get when you are using seed 10. Okay, so like this. So we are getting negative numbers like this, and we can also change this data type to float. Okay, so when you are creating this, what you can do is by default the data type is integer. Okay, by default the data type is integer. So I can mention the data type as float. Uh, one second. np dot float. So you can mention float like this. Okay. Let me check. One second. Normally this should work, but np dot float 60. Let's do that. Even though it is not okay. Fine. This is not working for this one. Maybe we will use another package. No need of package, but okay. So let's see one more thing. We dot random dot random. Okay. So by default, this queues between 0 to 1. Okay, let's give 10, comma 10. Okay, fine. So this is giving normal values between between 0 to 1. I think, yeah. Let me give an option to comma 4. Okay, 0, 1. Okay, fine. So there are two other things that I wanted to show you, which is rand and randn. Um, so these gives completely the float values only. Okay, floating point values only. It will be generating. Okay, so normally when you want to generate random dot rand n, so let me give the shape. So you can see when you are using rand n, you're getting the values from even negative values also are there. Okay, so the thing is that this is called this one is going to be uniform distribution, we call it in, as per statistics. Okay, so this is uniform distribution data which ranges from 0 to 1. Okay, and this one is normal distribution data which ranges from -3 to +3. Okay, -3 to +3. So between these only the output will be there. These two are very important when we deal with the data when different bigger data sets, Excel sheets. Okay, like a large number of rows and columns if we have, so we'll be dealing with that. Okay, so normal distribution concept is very much important when coming to the data science. Okay, so that we will introduce when we go into statistics. But normally, so generally a normal distribution is basically like a bell curve. Okay, so we should normal distribution. So we call these things. Okay, so this is a normal distribution picture, so which ranges from -3 to +3 values. Okay, so we'll discuss in detail more about it later. Okay, so that's a normal distribution. So these are the values that ranges. Okay, so if you want to generate values between like this with a different shape, you can mention your shape and you can get your own data. Okay, so that's like this you can use a random package with different values. Okay. Mm, okay, coming to the next thing. So when you generate your data, okay, let me store these into arrays. Okay, array 8, this one I'll store this one, array 9. Okay, so from this data there are few things that I wanted to show you, which is finding out a maximum minimum, okay, of the data and all. Okay, so we have array 8, right? So what you can do is, so out of this array 8 you can directly call dot max, so it will give you the maximum value. Okay, array 8 dot minimum, so it will give you the minimum value. Okay, so maximum value and minimum value is fine, but next thing is that what I want to show you is, so array 8 dot argmax, So argmax is nothing but it is going to show you the position. Okay, it is going to show you the position at which position the maximum value is there. So you can see the maximum value is 0.8706. So which is this one. Okay, it is in the position 2. Okay, it is in the position 2. As we know, indexing always starts with 0. So this is 0, this is 1, and this is 2. That's what it is saying. Argmax, it is showing us that it is in uh, uh, it is showing the value which is the maximum value, the position of it. Okay, and similarly if you do array 8 dot argmin, so it gives us the position of the minimum value, and it is in the 12th position, which is 0.140. Okay, 0.140 arg8 dot min. So this one. Okay, so this is the 12th position. Okay, this is the 12th position, which is the minimum value. And I wanted to show you one more thing. Argmax. So you can mention access. So basically what happens is, so when I'm saying access is equal to 0, it is showing the maximum value as per the access. So when I'm saying access is equal to 0, it is showing column wise maximum value. Okay, so that means in the first column you can see 0.61 is the maximum value. Okay, that's why it is showing the 0th position. Okay, and in this one you can see in this column 0.818. So this is the maximum value, so that's why it is showing the first position. And in this one we can see 0.870 is the maximum value, so that's why the position is 0. And here we can see 0.723 is the maximum value, so that's why the position is 3. Okay, so like this you can find out based upon the access. And similarly array 8 dot argmax of access is equal to 1. Okay, so this means row wise, okay, row wise maximum value. Okay, so execute this. So you can see there are arg, okay, arg8. Okay, so arg8 dot argmax. So in this one you can see in this row we have 0.87, which is in the second position. Okay, and this one 0.81, and that is in the first position, and this is 0.7, which is the maximum, and 0.81, which is the maximum. Okay, the same way you can do arg minimum also. Array 8 dot argmin of access is equals to 1. Okay, so this is going to show you the minimum. Array 8 dot argmin of access is equals to 1. Sorry, argmax. Already I've shown, right? Sorry, argmin access is equal to 0. Sorry. Yeah. So like this you can find out the minimum value and maximum value row wise, column wise. Okay, in each row what is the minimum value, in each row what is the maximum value, like that you can find out. Okay, so yeah, so like this you can find out the minimum value and maximum value from an array. Okay, and coming to the next thing, I would like to show you next thing is indexing. So let me take the bigger array of 10 by 10 matrix I've taken. So array 10 is equals to this one. Sorry, I'm using arranger. np dot random dot randint. So I'll give 0 to 100 with a shape of 10 comma 10. Okay, I will use random dot seed. Okay, I can use any number. I'll use triple name. Okay. So array of 10. So this is the array which has 10 rows and 10 columns. Okay, 10 rows and 10 columns. So till now in indexing, when we do with the list or set list or tuple or anything or strings, so we only have did with one dimensional data. Okay, but coming to two dimensional data, it is a little more complex. Okay, so when you are doing indexing, normally what you do, list, if you have a list, okay, so generally what you do, you will give start position, stop position and step position, like this you will give. But coming to the case of array, so in array what you'll do is, so you'll have two things, right? One is rows and one is columns. You have to do row indexing as well as column indexing. Okay, so row start, row stop and row step, comma, column start, colon, column stop, colon, column step. Okay, so this is how indexing happens in arrays. Okay, so for example, if you wanted to uh, get these two values and these two values, okay, 64, 92, 8 and 8. So the position of the 64 is 0th row and first column, and sorry, 0th row and 0th column, and coming to 92, this is 0th row and first column, and coming to this one is first row, 0th column, 1 by 0, and this one is 1 by 1. Okay, so 0 by 0, 0 by 1, 1 by 0 and 1 by 1. Okay, so we clearly know from where we have to start and where we have to end. So let's array 10 of in the rows. Okay, row start, what is the row starting value? Okay, row starting value is 0th position. Okay, 0. And what is a row stop? We always know in indexing, if you are putting value n, and that means it goes till n minus 1. Okay, so we know we have to stop at first row, so that means we need to put 2. Okay, we need to put 2. So now we are pointing out to this whole two rows, 0th row and first row. Execute it, you are going to get both whole big rows. Okay, whole bigger rows. Now what we'll do is, I'll copy and I'll paste here. Okay, now I got these two rows, and out of these two rows I need only the first two columns. Okay, only the first two columns. So in the columns part, I'll start with 0th column. Okay, and I will end with, I have to get till the first column, so that's why I'll end with the second column. So I'll put 2. Okay, execute it. Finally you got 64, 92, 8 and 8. Okay, 64, 92, 8 and 8. Like this you have to mention row starting value, row stopping value, column starting value and column stopping value. Okay, yeah, so any doubts in this one or any part anywhere? Okay, so I will go more in depth on indexing tomorrow. Okay, I'm going to stop the class now. I'll continue the class tomorrow, more with indexing. Okay.